Hello friends, this video on Binomial Theorem Part 10 is brought to you by examfear.com. No more fear from exam. Before watching this video, you should have watched Binomial Theorem Part 1 to Part 9. Let's take this example where we have to prove that expansion, the middle term, the expansion of 1 plus x to the power 2n is this. We have to prove that in the expansion of this we get the middle term and this becomes this. So as we can see, 1 plus x to the power 2n. 2n is even number. So the number of terms in the expansion is 2n plus 1, that is odd number. So the middle term will be 2n. This is 2n divided by 2 plus 1, that is n plus 1. This is the middle term. Now we know that this n plus 1 is the middle term. So now we know that tn plus 1 is the middle term. So tn plus 1 is nothing but 2n, because total number of term is 2n, c of n plus 1, n, because this is tr plus 1, cn, and we have 1 to the power 2n minus n into x to the power n. This is the tn plus 1 term. This is nothing but two n cn x to the power n. That is 2n permutation divided by n permutation divided by 2n minus n permutation x to the power n. This is nothing but 2n permutation or 2n factorial divided by n factorial divided by n factorial into x to the power n. Now if you see what we have to prove something like this: 1, 3, 5. This is all odd term into 2 to the power n, x to the power n by n factorial. So what we'll do, we'll try to take out all odd terms and all even number terms. So 2 to the power n factorial is equal to 2n into 2n minus 1 into 2n minus 2 into 2n minus 3. It is still 1, and divided by n factorial into n factorial x to the power n. So what we'll do now, we'll first separate the odd part and even part. So odd part is like this: 1, 3, 5, 7, 9. We'll do this till 2n minus 1, because 2n is the even number. This into, we'll now separate the even part: 2, 4, 6, 8, 2n by n factorial into n factorial, and here we get x to the power n. So what we have done, since we have seen in the answer we have all odd part and even part different, so we have clubbed all odd part here and even part here. As we can see, if we have 1, 2, 3, 4, 5, 6, we can also write this in this form: 1, 3, 5 into 2, 4, 6. 2, 4, 6, if it is still 6. So we have clubbed here all odd part, even part. Similarly, what we have done here, we had 1 to 2n all multiplication. So we have clubbed odd part and even part. So now what we'll do, we'll take 2 common. Everything has 2 common, 2 common. So now let's go to the screen. So what we'll get here is 1 into 2, 3 into 5 into 7 into 9 till 2n minus 1. And here we have 2, 4, 6. I'm writing everything same, whatever was there in the last screen. I'm not making any changes here because it's a new page altogether. A to the power n. This was the thing, x to the power n, sorry. Now what we'll do, since we know 2 is common here, all are multiples of 2, and in the question also you see we wanted something to the power n, x to the power n. So what we'll do, we'll take 2 common here. So this guy will become 1, 3, 5, 7, 9 till to the power n minus 1. And here since we have 2, 4, 6, 8 to 2n, we have n terms. So we take common, this become 1, 2, 3, 4 till n. And this is n factorial into n factorial. And this is x to the power n. So what we have done, we have taken all 2 commons. And there are n number of terms which have 2 common. It is all multiplication. So it is 2 to the power n into this number. You please make a note of this, what we have done here. It was 2, 4, 6, 8, 10 to the power 2. We multiply this to 2n. What we have done, we have taken 2 to the power n common, because we are taking 2 common from here, 2 common from here, 2 common from here. From all the points we have taken 2 common, and there are n number of points, so 2 to the power n, because n times we are saying 2 into 2 into, we have taken common, and this became 1, 2, 3, 4, 5, 6 till n. Now we observe that n is equal to this 1 into 2 into 3 till n is equal to n factorial. So we will cancel this. So what we have got here is 1 into 3 into 5 into 7 till 2 to the power n minus 1 into 2 to the power n divided by n factorial into x to the power n. And that was our question. If you see, this was we were supposed to prove. We have found the nth term, and this is exactly equal to what we have found. So we have proved that the middle term of the expansion is this. Let me repeat what I have done. This expansion was 1 plus x to the power 2n. We know 2n is even number. So that means total number of term in this series will be 2n plus 1, and that is odd. So for this, the middle term is 2n by 2 plus 1, that is n plus 1. So we found tn plus 1, and on solving this, we found that tn plus 1 is equal to this. So we have found the answer. Now the next question is we have to find the coefficient of term. So here is a question where we have to find the coefficient of x6, y3, the expansion of this. So what we have to do, we have to first expand this, and then we have to find the coefficient where the term is this. So if you see, we will find first tr plus 1. For this, any term tr plus 1 is equal to 9cr, because the n is 9 here, 9cr into the x to the power 9 minus r into 2y to the power r. This is ncr. Now we are told that this term is equal to x to the power 6 into y to the power 3. So we can say x to the power 9 minus r into y to the power r, because I am taking just the power of 6, is equal to x to the power 6 and y to the power 3. Correct? So if you compare this term, we get r is equal to 3. Here also, if you see, 9 minus r is equal to 6. When I say 9 minus r is equal to 6, so r is equal to 3. And here also r is equal to 3. So that means r is equal to 3, that is confirmed. So we have to find t of 3 plus 1. So what do you get here? T of 3 plus 1? 9c3 into x to the power 6 into 2y to the power 3. So what we get is 9c3 is nothing but 9 permutation by 3 permutation into 6 permutation into 2 to the power 3 into x to the power 6 y to the power 3. And when you solve this, this becomes 9 into 8 into 7 into 6 permutation by 3 into 2 into 6 permutation 2 to the power 3 x to the power 6 y to the power 3. Why I have done this? Because I wanted to cancel 6 permutation, and 3 into 2 I can cancel. 3 is 4 and this is 3. So what I get is this, I get is 672 x6 y cube. So the coefficient of x6y cube is 672, and that is our answer. Let me repeat what I have done here. So we were supposed to find the coefficient of this in the expansion of this. So we have found the r plus 1 common term, we got this, and then we have compared x to the power 9 minus r and y to the power r with x to the power 6, y to the power 3, we got r is equal to 3. That means we are talking about t of r plus 3 plus 1, that is fourth term. So fourth term is equal to this. We solved this and we got 672 as a coefficient. Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors, and much more. Thanks once again.